Hello everyone and welcome. I'm Rick Anthony and I'm joined here with Kashish Wadhwa, and we're both from the Amazon Inspector team, and we're very excited to talk to you about Inspector and a new capability we launched to detect vulnerabilities in Lambda functions. So today we're going to give you a little bit of background about Amazon Inspector. Kashish and I were here last year at reInvent, almost a year to the day, to introduce the brand new Amazon Inspector. So we'll go into that. What do we mean by that? We'll talk about what problems was Amazon Inspector designed to solve, how it works, how it achieves those goals, and then I'll hand it over to Kashish and he'll give a demo and talk about how we've extended it to support serverless functions through Lambda. So, starting with what is Amazon Inspector? So, Amazon Inspector is an automated vulnerability management service that continually scans workloads for software vulnerabilities and unintended network exposures. One of the things I really wanted to kind of make clear before we get too far into Inspector is that there's two inspectors that are on AWS. There is the original Inspector that we launched in 2016, and then there's the one that we launched last year. So the original one in 2016 is called Amazon Inspector Classic, and then the new one's just Amazon Inspector. And we launched that new version because of a couple of challenges that we saw with how customers were doing vulnerability management, either through traditional methods or through Classic. And one of the big changes that we made was to really build it for the cloud and make it a continual scanning system. And what do we mean by that? So we wanted to make Amazon Inspector easy to use and low administration, easy enablement, and continual monitoring, where Amazon Inspector decides what to scan, when to scan, so that instead of having a system where you schedule things and have to worry about, am I seeing everything in my environment, Inspector takes the burden for you. Okay, so a couple of the main challenges that we were looking to solve. Number one, we wanted to build Inspector for the cloud. So the cloud it's elastic, it's flexible, it's fast. When we talk to customers, one of the challenges they talk about is it's hard for me to know what are all the accounts that just exist within my organization. What are all of the resources? How do I know that I'm scanning everything when resources can come up and go down so quickly? That's one of the things we wanted to solve with the new Amazon Inspector. Number two, we wanted to tell customers how to manage vulnerabilities in near real time. One of the challenges we saw is that customers, because they were using vulnerability management in a very traditional sense of scanning once a week or once a month or once a quarter, they had to be really hyper aware of what vulnerabilities were out there, because they had to know, hey, if there's a brand new critical vulnerability, is this important enough for me to now scan outside of my normal window? We wanted to kind of take that responsibility away and hand it to Inspector so Inspector could do the work. Number three, we saw that customers, as they went on their journey from scanning, using EC2 workloads to container workloads to Lambda workloads or serverless, they were using different tools or they were buying different modules. And we wanted to give customers a way where they could do everything with one tool. So that's why we support both EC2, we support containers, we support Lambda functions through Inspector. And finally, we saw customers struggling with, once they had all the data, what do I do with it? How do I action this data? So we built Amazon Inspector in order to make it easy to, number one, know what's the state of my environment, number two, know what my findings are, and number three, easy methods to take those findings, send them into other tools, and action them. So how do we do this? How does Amazon Inspector address those challenges. We're really going to talk about 3 areas or 3 pillars of Amazon Inspector functionality. Number 1 is what we call frictionless activation and management. Number 2, we're going to talk about continual vulnerability monitoring. And number 3, we're going to talk about how to prioritize and contextualize the results. Okay, frictionless activation. So the new Amazon Inspector is integrated with organizations. So one of the problems we talked about is how do I know what all of my accounts are? If you're using AWS organizations, you can very simply plug that into Amazon Inspector, and now Inspector knows all of your accounts. And with a single click, you can now activate Inspector everywhere. And so one of the things that this allows you to do is to ensure I've got coverage on everything, and Inspector has a capability where you can say, okay, Inspector, as you see new accounts, automatically enable yourself. So now you're eliminating gaps in your coverage, and now you have security by default because everything is now configured through organizations. The second benefit of this is that if you're using organizations, you have a single pane of glass where you can see everything for your organization. So the way Inspector works is you assign a delegated administrator, you use that administrator to enable Inspector, configure your organization-wide settings, and all of the findings and all the data that Inspector collects now shows up in a single pane of glass as you view it as that delegated administrator. And if you want even more flexibility, we allow you to send that data out to Security Hub, because Security Hub has very nice features for bringing all your data into a single region. So as an example of the power of this, we recently had a customer onboard and enable Inspector for 7,000 accounts. And they did this with just a handful of steps. Number 1, they had their organization set up already. They came to the Inspector console. They assigned a delegated admin, enabled Inspector, and through that delegated admin account, they just said, okay, number 1, I want all new accounts enabled, and number 2, I want to enable all existing accounts. And that was it. They were done. As Inspector turned on, it looked at all their resources, it started doing assessments, and from that single view now, they can see all of their results, all their findings for 7,000 accounts. Number 2, continual vulnerability monitoring. So one of the challenges customers tell us about is, how do I know what I have? All of my teams are constantly creating new resources. How do I know that I'm seeing everything? The cloud is fast, resources come up, resources go down. Amazon Inspector keeps track of all these resources for you. When you activate Inspector, it inventories everything in your account. So it inventories all your EC2 instances, it inventories all your container images, and as you will see later with our demo, it will also inventory all of your Lambda functions, and it will hook into AWS to monitor all your activity. So if you launch a new EC2 instance, Inspector is aware. If you push a new container image, Inspector is aware. In the demo, you'll see us create a brand new Lambda function. Inspector will become aware of that, and it will scan it automatically. So as an administrator, I have no work that I have to do. Inspector just finds it. And Inspector will then also monitor what's installed in those resources and reassess them as needed. So vulnerabilities are being published every day. And like we talked about, you don't want to have to be an expert of, how critical is this brand new vulnerability? Do I need to go outside of my patching cycle? Amazon Inspector monitors all the vulnerabilities, and as new ones are published, it will look at your resources, it will pick the ones that are impacted and automatically reassess those and generate findings for you. Also, if you patch your resources, Amazon Inspector is aware. It will go in, it will reassess, it will see that you've remediated your issue, and it will close the findings for you. So constantly when you go and look at Inspector, you're seeing the state of your resources as they are at that moment. So one of the examples of this, a few weeks ago, there was a OpenSSL vulnerability that was rated, I think some vendors rated it as critical, some rated it as a high vulnerability. And for customers that were using Amazon Inspector, they didn't have to worry about it. So as vendors like Red Hat, Ubuntu, and others did their analysis and published their findings for that vulnerability, Inspector automatically pulled that information, found the resources impacted, and just reassessed them. So customers who were worried about that really had nothing they had to do. They just came into work that morning, they logged in, and they saw, oh look, Inspector's aware of this vulnerability, it's already done the work for me, here's my status, and this is where I'm at. And then the third pillar of Amazon Inspector, prioritizing and contextualizing results. So we know that vulnerability systems can generate a lot of findings because customers have a lot of resources, and sometimes it can get very overwhelming to know, what should I work on first? What's really important for me and my environment? Inspector tries to help you with that decision making by providing something we call the Amazon Inspector Score. So the Amazon Inspector Score takes into account the severity of the vulnerability, takes into account the network accessibility of your resource, it takes into account exploitability and other factors, and then will tell you how important that vulnerability is to you and your environment so that you can prioritize better and pick the things that are really important to address first. In addition to this, Amazon Inspector keeps track of all of your findings holistically. So if you do patch or you do delete a resource, Amazon Inspector is automatically closing those so that you have a current state of the art. And if you want to take that data and send it into another system, those findings automatically flow into Security Hub for easy viewing. We also send them out to EventBridge so customers can take action on them, either feed them into ticketing systems or write their own remediation scripts through things like SSM Patch Manager. Okay, so a little bit of background on Inspector. So how does those things work for serverless? I'm going to turn it over to Kashish to continue.
Thanks, Rick. Before we move on to security for serverless functions, one key point that Rick brought up was around using EventBridge to automate remediation. So we did recently publish a blog with CloudFormation templates where we showed how you could take or enable Inspector, activate it, and if you have that solution in place, that would automatically remediate all your findings in real time using SSM Patch Manager. So that was pretty impactful because customers not only could identify these vulnerabilities in real time, they were automatically getting patched, or EC2 instances were getting patched in real time also. Another blog that we recently published was around container images, where while it is important to scan for vulnerabilities, more important thing is to prevent the deployment of those images or those vulnerable images in production so that it's not exploited. If you look at some of the studies done by prominent vendors in this space, between 2020 and 2021, the time took to exploit a vulnerability has gone down by 70%. So there are bots that as soon as your EC2 instance comes up, they will try to poke it, they will try to see how we can exploit it. And if there is a critical vulnerability like OpenSSL or any critical vulnerabilities that have been published in the last year, it's really easy for them to exploit it even before you know it. So moving on to security for serverless, and as we were talking about, it is really important for customers to kind of get a whole picture of their overall landscape in compute world. We saw 10 years ago, we started with EC2 instances, which is virtual machines. Then we moved on to containers in the last 5 to 6 years. Now the industry trend is to move towards serverless. I have spoken to a lot of customers that only use serverless now. They don't even use containers just because it's easy to use. They don't need to have administration teams just to manage the infrastructure. So with that move, we thought, since customers are using this for vulnerability management, inspector of vulnerability management for EC2 instances and container images, it is equally important for serverless functions, and soon compliance requirements will also cover those in addition to containers and traditional virtual machines. So talking about the shared responsibility model for serverless functions. Even though it is completely managed, AWS manages the infrastructure, the hardware, even the compute, but the applications that you deploy on that serverless infrastructure is still responsibility of the customer. So think about the code that you write is still susceptible to exploitation, or the dependencies that you use are still valid for exploitation. One of the major things that we have seen with Lambda functions is that there's an exploit called well poisoning, where if you have a certain package which is vulnerable and you maintain some sort of repository, and regardless if your function is accessible through API gateway or external network or not, if you're using that specific package, it could still be exploited. Then there are resource configuration and IAM issues with functions which can still be exploited. So there are a lot of things that makes it really critical for us to tackle the problem around serverless functions or Lambda functions also. And we wanted to give a single pane of glass, because if you think about it, the same, let's say hypothetically, there is a vulnerable package, Python 2.7. Now, you could use the same package in your EC2 instance, in your container image, and in your serverless functions, which is Lambda functions. So you don't need 3 or 4 solutions or different modules or different solutions to kind of tell you the same thing with different details. Any solution should be able to give you that single source of truth, and the goal is that you are able to go and remediate or update that package or issue that guidance to your organization, that we don't need to use this package. So for example, internally we had a similar issue in the past where there was an organizational level decision that you can't use a specific package anymore just because it is vulnerable. So we had to identify, even in our systems, where are we using that package. So it's really critical to have that inventory where all these packages are in my entire environment. And then it's about how do I go and rebuild it, patch it. So this is one of the reasons we tried to bring this up forward before any other features. So what's new? Essentially, how would the scanning for serverless functions work? I will show this in the demo, but how Rick explained, we have tried to make a very consistent operating model for serverless functions also. So for existing customers who are already using Amazon Inspector, they have to go to their account management page and just with one click can enable all their accounts for Lambda standard scanning. With that, as soon as they click that, what will happen is we will go and discover Lambda functions that exist in their accounts across all the accounts within their organization, and we will automatically start discovering them. As soon as they are discovered, we will automatically scan them for software vulnerabilities. So what I mean by that is we will go and extract the Lambda function. We will look at all the dependencies that are being included in that. We take an inventory of that, and we will generate findings. And let's say if you update a function, because I've talked to a few customers who have regular updates scheduled. If there's, let's say, a dependency, they continuously update those functions every day or sometimes every 12 hours so that they make sure they are using the latest dependency version. So in traditional vulnerability management, what you would have to do is either you scan every day, every week, or every month, whatever that is. It still leaves the room to possible exploitation because you still have that vulnerable package or overall software being used in your production environments. With Inspector, since we auto-discover not only when it is deployed, when you update a function, and all this is in near real time, I would say, 30 to 45 minutes, or most of the times it will be within seconds or minutes, but at max it could take 30 to 45 minutes. So as soon as you update a function, we will automatically discover, and we will trigger a scan, which will go and generate new findings if there is any delta in the packages that are used or the version of the packages that are used. And on the other side, so this is what we kind of monitor your environment. Then we also monitor CVE landscape. As Rick alluded to earlier, we built a purposeful vulnerability intelligence database for the new Inspector, and we consume over 50 sources in our database, and that includes some of the prominent sources like Sneak intelligence that we procured licenses for. We also recently procured additional licenses from some other vendors for threat intelligence. And one of the things that we have added now, we not only give you, these are the findings, we also give you additional vulnerability intelligence. So think about when was this last CVE exploited? So CVEs have a CVSS score, as I'm sure you all know. Let's say there is a CVE with CVSS score of 10.0, but it hasn't been exploited in the last 5 years, right? And there is a CVE with a CVSS score of, let's say, 9.1. Even though the score is lower, but we know that it has been exploited yesterday or this morning in the wild, not in your environment, but in the wild, that automatically becomes more important. And if there is a fix available, if you correlate both that data, it's really easy for you to identify these are the resources or these are the findings I need to address first, and then I can tackle the later ones. Because one of the things we consistently heard from security teams, including internal security team, that it's really hard to even go and remediate the criticals and the highs, let alone the mediums and the lows or the informationals. It's just the sheer volume of findings that are generated, not just in Inspector, just it's the nature of the space, and it's just really hard to remediate that. So like Rick was telling you about the prioritization, we do that for you. Our main goal with Inspector is that security teams should not be focused on managing a solution, deploying an agent, or just the operational overhead of that is associated with vulnerability management. They should be focused on remediation, implementing compensating controls, or just focused on improving security. Maintaining a solution should be good enough to do that. So that was our main tenet when we decided to rebuild Inspector. And going back to prioritization, within Inspector, we do that. So if you, and I will show that in the demo also, we have a panel on the main dashboard called risk-based remediations, where we look at holistically your whole environment, and we identify 5 packages. Top 5 packages, what we call 5 packages on fire, and based on number of CVEs attached to it, the criticality of the CVEs, and number of resources that are impacted by those packages, or that have those packages, we kind of identify those 5 things. And our opinion is that if you go and try to patch or remediate those first, that will reduce your risk posture significantly. Obviously, you have to implement others also, or remediate others also, but this is a good starting point. Then the last thing about integration with EventBridge and also Security Hub. So some of the customers have already automated their ticketing system. So since Inspector does everything in real time, every time there's a new finding generated, we would send an event to EventBridge. Every time a new resource is discovered or the state changes, so let's say if it is terminated or an instance is stopped or a Lambda function is deleted or a container image is deleted, we send all sorts of events. And obviously in EventBridge, you can create different rules on how you want to kind of manage those events. You can get as granular as you want, or it could be as broad as you want. So what customers have done, they have used this mechanism to automate their ticketing systems. So for example, as soon as an EC2 instance comes up, is launched, inspector will detect it, scan it, generate findings. And as soon as we generate findings, there will be an event bridge notification or an event saying this is a new finding generated, these are the details, and we also have the resource details. So things like tags attached to the resource, instance ID, or Lambda function ID, and so forth and so on. So based on that, customers can automatically route or create tickets and route it to the appropriate team so that they don't have to worry about manually creating teams. In the past, I've seen customers hiring people just to create tickets. Their whole job is to see what the scan results are and then go and create tickets. So we are trying to reduce all that operational overhead, and the same mechanism could be used for automated patching also, which I was referring to the blog, and there's a slide towards the end that has links to it, but if you go to Amazon Inspector's website under resources, we have all those blogs also listed. So the whole goal is, so with this launch, as I've said before, you will get a single pane of glass across all compute types, and it's just easier for you to identify where all your packages are and kind of have that supply chain traces in your environment. One thing I do want to note is that a lot of the customers typically have Lambda functions kind of deployed, but they are not getting invoked in a while. So we also made the solution intelligent enough to filter out those functions that haven't been invoked in a while. The reason behind that is to control costs or spend for the customers. And if, let's say, you haven't invoked something for 6 months, we won't pick it up on enablement. But let's say tomorrow you do invoke it. So we have made that intelligent enough that as soon as it is invoked, it does come under inspector coverage, and we start scanning that, and then it will be monitored throughout until it is getting, there's a period when we will continue to monitor it. So I'm going to transfer or switch to the demo now, and then we can take questions after that in Q&A. So what I'm going to do is I'm going to log in through my org management account first, just to show you how you can assign a delegated administrator account and how easy it is. So just to show you how the organization is set up, if you can see, this is the org management account that we use to log in. And this is the account I will assign as the delegated admin, and this is another member account in the org. And when I go back here, all I have to do is when we get started, here you have to assign a delegated admin account, and you just have to provide the account ID. And what will happen is, once you click on delegate, it will not only delegate the admin account, which can act as a central inspector admin account, which has visibility into all your other accounts, but also all the findings are consolidated into that one account. Now, while it's getting delegated, I'm going to log in through the delegated admin account to show you how it would look like. So when you log in, this is the delegated admin account, and this is how you see inspector would look like. So we give you the whole environmental coverage details. So, and I'll click on each one of these and show you how it would look like and what the benefit is and what the use cases are. But essentially, when you log in, this is the first page you will see. You will see your real-time environmental coverage, which means how many accounts are being used or activated with Inspector. So you can see 3 out of 3 accounts are enabled. Instances, we are giving you 85% instances are being covered by Inspector. That is 12 out of 14. And when I click on that, and I'll show you in the coverage pages, we give you actionable guidance. The 2 instances that are not being scanned by Inspector or monitored by Inspector, why not? Similarly, for container images or container repositories and Lambda functions, we give you coverage details. And similarly, for critical findings, we have this page, like real-time dashboard for you so that you can see your organizational vulnerability posture at any given time. So our whole goal is not to make it more like a traditional vulnerability management solution. It's more to build it more like a security operations center so that you don't have to worry about the operational overhead. You just have to monitor the real-time data that you get from Inspector. So if you click on it, or you can just go to account management page also, you can see there are EC2 scanning, ECR scanning, or Lambda scanning. And all you have to do is click here and enable all. And if you don't want all types of scanning, we do give flexibility. If you just want, let's say, EC2 scanning or Lambda scanning, you can just turn on that. And we also provide additional feature for new member accounts. So let's say today you have only 10 accounts in your AWS organization, but you plan to add 1 more. So you don't have to come back and re-enable Inspector for that new account. If you have this setting turned on, the new accounts will automatically be onboarded to Inspector without any manual effort. So going back to instances, and you can go back or go through account management also. You can see the coverage pages through there also. But essentially, we tell you how many EC2 instances are we scanning, and the ones we are not, why not. So you can see this is being actively monitored. This one is unmanaged. So we do require SSM agent only for EC2 instances. So if you're already using SSM agents in your environment, you don't need to do anything else. But if you don't, you do need to have SSM agent for EC2 instances only. For container images or Lambda functions, you don't need any additional agent or a software. We automatically get that from the service.
And just to jump in, this is one of the differences between the new Inspector and Inspector Classic. So for those who used the older Inspector, we had a dedicated agent that you had to deploy and kind of manually manage on your own. And customers just constantly told us, like, we just don't want another agent. You know, we're already using SSM. Our security teams have blessed it. Like, please make that work for us. And so that's why you see that change between Classic and the new Inspector.
And similarly, you can see for container images, and you will see unsupported OS or scan eligibility expired, and we can go through that if you have questions around it in Q&A. But essentially, we give multiple configurations for container images on how long you want it to be monitored for. It could be 30 days, 180 days, or lifetime. So depending on each customer, you have that configuration available.
Yeah. And those settings, those configuration settings, those are set by your delegated administrator. So you don't have to go in and set them in every single account. The delegated administrator is that single point where you can decide, how do I want this configured for my organization?
And similarly, for Lambda functions, you can see, what are the resource tags, it is actively monitored, and so forth and so on, runtimes. So before I deploy a Lambda function, I do want to show you one of the unique things that we do with network reachability scans first. So in parallel to vulnerability scans or CV scans that we do for EC2 instances, we also do network scans. And the network scans that we do are kind of unique in the sense, since we are an internal service, we get data from security groups or other services. So what we can do is we can identify open paths to your ports from the internet or any VPC, and I would say VPC edges. So think about internet gateways, load balancers, or transit gateways. We identify paths from the internet to your instances. So if I just filter on network reachability scan or network reachability findings, you can see this port 22 is reachable from the internet gateway. And we do give you the exact path. And if there are multiple paths, we will generate multiple findings. So you can say this internet gateway, this network ACL, this security group, this ENI, and this instance. This is how the path is. And if it is unintentional, you might want to go and remediate that versus letting it be open. And what we do is, for our contextualization, as Rick alluded to earlier, we take that data and we correlate it with the CVE data. Now, if I show you an example of how inspector score is generated and how it is impactful, let's take an example of this one. So on this instance, we identified this CVE 2017 for curl and lip curl. We do give you kind of a high-level description of what the vulnerability is about. Then we give you the severity, which is determined by the inspector score, what kind of vulnerability it is, if there is fix available, if there is an exploit available. So exploit available here is the feature we are launching as a part of this launch, which I called out earlier, where we do give you the information that if there is an exploit available, and we monitor darknet for it. We have our internal threat intel groups that monitor known hacker groups for these. So we monitor the whole landscape to see which CVs are actually being exploited in the wild. So for fix available, you can see these are the affected packages by this CVE. So curl and this version, this epoch, this release, this architecture. And we also give you fixed in version. So not only which version is affected by this CVE, but how it is, or where it is fixed in. If it is not fixed yet, which means like vendor hasn't really released a fixed version to address the CVE, then you will see fix available as no or partial. So partial is when, let's say if there are two packages, there is fix available for one, but not the other one. So it will be partial, and if none of the packages have fix available, it will be no. And we give you scores, all type of scores. So you can see CVSS 2.0 score from NVD, CVSS 3.0 score from NVD. But if you look at it closely, CVSS score from NVD is 9.8. But here, inspector score is 8.4. We have reduced the score based on, and we are being very completely transparent about it. If you look at it, what we did was we looked at the CV metadata. And if you look at attack vector, what it means is that this CVE can only be exploited remotely. And we determined that your instance is local, which means it doesn't have any path from the internet. And we adjust the parameters to generate an inspector score that will eventually determine the severity of that finding. Now, we didn't invent our own calculator. We are using industry standard calculator to calculate the inspector score, but we just adjust the parameters in that CVE vector.
And one thing that's important to point out, that network reachability, we're not doing that through network probing. So we're not sending data into your environment. What we're doing is we're looking at your configuration, and Amazon has provable security tools that basically guarantee us that, yes, there is a path, no matter, from the edge of the VPC in. So just to be clear, this is without agent, without probing, this is where that's coming from.
So now what I'm going to do is I will deploy a Lambda function. I did prepare some Lambda functions beforehand. So I'll just deploy this Lambda function, and I will show you what the function does in a minute once the deployment is done. And one thing we kind of didn't really talk about until now was layers also. As you know, you can use layers as a part of your Lambda function. So we do scan layers also. So if any function that we are scanning, and it has like 5 or 10 layers, not only we will show those layers or identify findings in those layers, we will also attribute that finding to that specific layer so that you know if you go and fix that layer, it could impact multiple functions at once. So we do have that capability also. Yeah, it takes about a couple of minutes to deploy. While it is getting deployed, this is something I wanted to call out, the risk-based remediations. So based on my demo environment, these are the packages which have the most critical CVEs attached to it, impacting most resources. So you can see these are the packages I need to go and update, and that is how you can remediate those. And for EC2, I do want to call out another thing. We map it back to armies. So if you look here in this panel, this army is being used by 4 instances. And since we are not scanning the armies directly, there is a baseline that you can see that, for example, 130 high or 228 total vulnerabilities are like a baseline. And there could be additional software in other instances, or you might have patched in other, but it gives you a good idea of what you need to patch or regenerate your army to see results. Let's see. Yeah, so this is deployed, and within seconds, you will see it has been discovered, and within a couple of seconds, it will turn to, yeah, so this is the function I just deployed. And you can see findings generated a minute ago, or a few seconds ago. So within like a minute or so, as soon as it is deployed, you can see all the findings for Lambda function. You can see if there's a fix available, if there's an exploit available for this one, and similarly for others. For example, this specific CVE, exploit is available, yes, and it was last exploited on October 24th in the wild. So it hasn't been too long. According to our intelligence, it has been exploited in the last month or so. And we do give you kind of which package manager, where exactly it is. So you can see if there are layers, which layer this package was consumed through, and you can see all the results there.
Kashish, are you going to talk about what environments we support with this?
Yeah, so at launch, or right now, we support 3 runtimes, Python, Node, and Java, because that kind of represents 96% of the functions in Lambda service anyway. But we do plan on adding support for other runtimes also pretty soon. Yeah, so this was mainly the demo. And before we jump onto the Q&A, I do want to talk about pricing a little bit, and then we can.
Yeah. Well, while Kashish switches over, I think there's a couple of things we really want you to take away from this. Number one, we've designed Inspector to be easy, low administration. Single click, you turn it on for your organization, you set it to auto-enable, and you can just ensure that, okay, I don't have any gaps in my coverage. Number two, Inspector does all the hard work of discovering your resources. So, as your development teams are doing new things, you don't have to worry about it. You don't have to keep track. Inspector will do that for you. And number three, we manage the findings. So as you patch, as you destroy resources, or as new CVEs are published, Inspector takes care of the details. We really want to get you out of the business of administrating a solution and into the business of remediating findings. And at the end of the day, we want you to have one tool that does it regardless of the compute, whether it's EC2, containers, or Lambdas. That's the goal with Inspector, and that was the goal of adding Lambda to this product.
So talking about the pricing, we have priced it pretty aggressively because we want customers adopt this feature, and It's not about making money for us. It's about making sure all your, all your compute environments are secure. So the way we price it is per Lambda function per month, and it is determined by inspector coverage. And for what that means is, as soon as it is deployed, which means inspector will discover it, until it is deleted or you exclude that function from scanning, we will calculate the number of hours, and we charge by that. And we prorate it by number of hours also. So 30 cents per month per function is in US East 1. And if, let's say, you have that function, you deploy it today, and you delete it tomorrow, we will only charge 1 cent. So we will only charge for 1 day. If it is for a few hours, we only charge for a few hours. So it is prorated. It's not like we charge for the whole month. And there is a pricing example there. For example, if you have 10 Lambda functions continuously monitored for 30 days, it'll be $3. If, let's say, you delete another set of 10 functions, but you delete them by after 15 days, we will only charge you for 15 days, which is $1.50, and then the total will be $4.50.
One of the important parts of that is we want it to be predictable. As you saw in Kashish's example, I think there was, how many supported Lambdas did you have, like 14?
7, yeah.
7? Okay. I can actually see the screen. So, in his case, if, with 7 Lambdas, if they were being monitored all month, it's pretty easy math. It's just 7 times 30 cents. So that was the goal. It doesn't matter if inspector scanned them once in the month or 100 times in the month. You're just getting charged for those 7 Lambdas.
And these are the blogs I mentioned before during my kind of talk before. These are also listed on our website. So if you go to resources on Amazon Inspector, you can see all the blogs. These are some of the critical ones that I wanted to make sure you kind of know about those. But others, there are many more blogs that we kind of write and we publish on a regular basis. I think we can take questions now.